Hello and welcome to Danomics. In this video, I'm going to be reviewing the capabilities and functionality within the water saturation interpretation module. To access this module, come here to the Central Module Selection drop-down menu and select SW Interpretations. This will bring up the relevant parameters and display for this module. Within the water saturation interpretation module, there are several different saturation calculation methods available. For example, we have the Archie, Siemens-Dew, Modified Siemens-Dew, Indonesian, Dual Water, and Waxman-Schmitz. In all of these, you'll have options for using an effective versus a total porosity within the equation. For this example, I'm going to be choosing the Archie total porosity method. There are several parameters that are available to be set, and we can use a cross plot to help us set these. In this case, we'll use the Pickett plot. And we'll adjust this to our zones of interest for this area. Okay, once we have set up our cross plot, we can make adjustments to things like our RW at surface. It should be noted that the RW at surface here should reflect the surface temperature set here. It's important that we enter a geothermal gradient, as all the calculations should be done at a downhole temperature. The Pickett plot can help us select the appropriate M and N values if we don't have these from core. In this case, a slightly lower M may seem appropriate in order to have the 100% saturation line run through the left-hand side of the data here where we see a water trend. You can see the results are shown here on the right-hand side. There are a number of parameters that can be set based on the other methods. For example, if we choose a Siemens-Dew method, we also need to set our resistivity of clay value. In this case, that's around 3 ohms. We can use the RT clay cross plot to help us visualize this. If we were using a dual water methodology, we would need to set the resistivity of the bound water. The RO track is shown here to help us set this value. And what we should be looking for is a near alignment of these lines of the RO and the deep resistivity where we know that we do not have hydrocarbons. So, for example, here we see good alignment in the lower Parkman where we are in predominantly shale, and here where we know we have pay in the upper portion of the Parkman formation, we can see that we have separation between the resistivity and RO lines. You can also choose to set the RW values for each zone by dragging and dropping the parameter overlay lines in the RW apparent track. The permeability methods are also set here within the water saturation module. There are several available methods, including Wiley-Rose, Coates, Timmer, Tissier, and Heslop methods. To see the parameters for these methods, click on the Advanced tab. This will allow you to access the P, Q, and R's that are part of these equations. When working in unconventional reservoirs, you'll typically need to change the scalar values on these. However, you should always be calibrating to core when available. If you have any questions about how to perform the water saturation interpretation, the permeability interpretation, or need help understanding the available plots, such as the Pickett plot, resistivity of clay, or the Buckles plot, as shown here, please feel free to contact us at support@danomics.com. Thank you.